Lesson 6a, Projectile Motion. Any object traveling through the air with no force acting on it, other than gravity, is a projectile, like a bullet, arrow, football, or soccer ball after they've been fired. Newton's first law is paramount in explaining projectiles. Also known as the law of inertia, a non-moving object will remain unmoving, or an object will remain moving, unless an unequal force acts on the object to move it or to stop it. A force is defined as a push or pull that can do work, or move an object. We will look at 4 types of projectiles in Physics 11. First is a free fall or dropped object, objects that are tossed straight upwards or vertical, objects tossed straight outwards or horizontal, and objects tossed up and out like a football, vertical and horizontal. This first lesson will look at free fall objects. If we lift an object to a stop, then drop it from a height, it will fall freely due to gravity. It will travel in a single plane and in one direction. It will drop down. It will not move left or right, forwards or backwards. The initial velocity of the object as we drop it from our hands will have a zero velocity. The final velocity will be determined by gravity. Gravity is equal to negative 9.8 meters per second squared, where the negative sign means downwards. Here's a strobe of a free-falling object. Note the increasing displacement for each strobe. The object starts at rest and then drops. The final image shows you the object displaces more and more as time passes. It is accelerating at a rate of negative 9.8 meters per second squared. Note that a free-falling object will start with a velocity of 0, but it will not have a final velocity of 0. It will acquire speed as it falls. Many students in grade 11 confuse the idea that the ball is stopping because it strikes the ground as final velocity. And when we calculate velocity final for a projectile, we look at the velocity just as it hits the ground. Our first example will look at a ball being dropped off a cliff. When the ball is released, the initial velocity of the ball will be 0. It will not have velocity in the x-plane or x-component, left or right, nor will it have any velocity in the y-component, the up and down direction. After the ball is dropped, its velocity will only change in the y-plane due to gravity. There is no unequal force acting on it in the horizontal. Acceleration due to gravity on an object near or on the surface of Earth is negative 9.8 meters per second squared. Since there is no forces acting in the horizontal velocity will stay at 0 meters per second. Our first question is, what is the ball's velocity after 5 seconds of free fall? We will ignore friction and air resistance. Because there is no forces acting in the x-axis, there will be no velocity change in the horizontal plane. We use the kinematic equation velocity final in y equals velocity initial in the y plus a times t. Velocity final equals 0 plus negative 9.8 times 5, which yields velocity final being negative 49 meters per second, where the negative sign means downwards. Question number 2. What distance will the ball fall during this drop of 5 seconds? Well, we know the initial velocity is 0 and the final velocity is negative 49. We also know that the time for the fall is 5 seconds and the acceleration due to gravity is negative 9.8 meters per second squared. Which kinematic equation should we use to solve this problem? 1, 2, 3, or 4? We have enough information to use any of the 4 equations, since we know VI, VF, T, and A. Let's solve for distance using equation number 1. D equals V initial plus V final over 2 times T. Sub in initial, final, and time. This makes D equal negative 24.5 times 5, which makes displacement equal to negative 122.5 meters, where the negative sign means down. Using formula 2, D equals VIT plus 1/2 AT squared, we'll sub in our values and we get D equals negative 4.9 times 25, which also makes displacement equal to negative 122.5 meters. Using formula 3, D equals VFT minus 1/2 AT squared, sub in our values, and we get D equals negative 245 minus negative 122.5, which is a double negative. It simplifies to negative 245 plus 122.5. D equals negative 122.5 meters as well. Finally, equation number 4. VF squared equals VI squared plus 2AD. We'll manipulate the equation so that D equals VI squared minus VF squared over 2A. Sub our values in, and we get D equals 2401 divided by negative 19.6. D equals negative 122.5 again. As you can see, there are multiple ways to solve kinematic problems. The key, as with most problems, is to identify which equation has all of the values that you need to solve for the unknown.